So hi everyone, and welcome to this session. This session is about preventing version sprawl in containers and virtual machines. I'm gonna start with a straight question. How do you treat your servers? Like cattle or like pets? And if you're unsure about the answer, these two questions might help you in answering that question. So what would happen if several of your servers are going offline right now? Would someone recognize that? Would someone happen to know that? Would that be visible? So would your user be impacted by that? And also, what will you do if one of your servers gets sick? So these two questions might help you in finding the answer to, are you treating your server like cattle or like pets? And the modern approach is to treat your servers like cattle and not like pets. And why is that? My name is Michele Bologna, and I'm going to show you how can you prevent version sprawl in containers and virtual images with SUSE Manager. So in my kind of open, SUSE Manager helps you in preventing that version sprawl. I'm a software engineer in the SUSE Manager team, and I co-developed the image building feature in the engineering team. So I'll be more than happy to answer all of your questions that you might have. So let's establish some ground rules of the house right here. We have a complex topic ahead of us, but if you have some questions, feel free to interrupt me and for general question at the end of this session. The agenda of this session would be discussing the approach of pet versus cattle and how we ended up in treating our servers like cattle and not like pets, and what are the notable problems of this approach, for sure, because there are problems with the cattle approach. And also we are going to show how SUSE Manager can help you in dealing with this problem and what is the workflow that we established to building images with SUSE Manager. And finally, we will have a recap of all the benefits of using SUSE Manager. And finally, the use cases of this particular appliance. And finally, as I said, we will have a question and answer. So pet versus cattle. Pet is an anti-pattern, as I wrote there, because if you're treating every server like pet, you are naming every server, you know them by name, and you SSH into them into the morning like a doctor, and you hand feed them. You SSH in the morning and check if they are doing well, you check on the logs. And like a pet, if your pet is gonna get sick, you are sad and you're not going to easily replace your server because it cannot be easily replaced. It's a unique snowflake to you, right? And it's usually servers like pets are manually built and managed. So every day you're going to check on their status, and you're worried when they get sick, and your users are gonna notice if one of your server is sick, right? While cattle instead is another different story, because every server is numbered and they are identical to each other. You don't know which one is, you can't tell the difference between each server, right? And one server goes down, it gets replaced on the line, and you take him out and you take another one in to replace the sick one. So you don't cure the sick server, you just replace them on the line. So these systems are usually built using automated tools. One tool that we use is Salt, and at SUSE we are officially using Salt a lot in our setup and also in our products like SUSE Manager, and I'm going to show you how. And those systems are designed to route around the failure. So every server, like I said, gets replaced on the line as soon as they get sick. And how we ended up like the cattle, what was the evolution that brought to the cattle approach? So at the beginning, there were the server craftsman era. So every server was manually built by professionals and was built using a recipe. So there was no handwritten formula to create them. There was no recipe. So every craftsman was creating a server from scratch using special instruction, and there were no story of how that happened. So there was no recipe to recreate another server. And then came the virtual machines. And then there is a plethora of solutions like snapshot, cloning, and then begin system administrators using scripts that they did write while dealing with virtual machines. And then began the era of configuration management software. So you have your own infrastructure written in a code, and you have your own configuration written in a set of scripts that your system administrator began to write, but only know them how to use those scripts. So typically they're bash script that every system administrator has, and it's a lot of complex system and hard to understand, hard to share the knowledge. Then we had infrastructure as a service. So on the cloud, you have a lot of infrastructure, and you can create your infrastructure as a service. So you have a provider that gets you the whole infrastructure, and you have a lot of tools to recreate your own infrastructure on the cloud. And finally, we have infrastructure as a code. So we have plain files with a common DSL, so a domain-specific language, to recreate your infrastructure. And that code can be easily managed. So typically, we have a version control management for versioning this particular kind of infrastructure. So your whole infrastructure, you get version that kind of infrastructure into a code, and you can see the whole evolution of that. Finally, we have containers, and these containers are an alternative to virtual machine, but they are not complementary. So you can use either one of them. So no problem with that. But the final tendency right now is to have an immutable production system where disposable virtual machine and containers can be easily configured at deployment time and can be easily replaced on the line, like cattle, like I said. What are the notable problems of the modern approach, like using cattle system like that? So we are in the era where we have virtual machine and containers, and we have 4 major problems. The first one is what we call configuration drift. Do we store the recipe to recreate the server somewhere, the containers or the VM somewhere? Do we have that recipe? And has the server changed and we didn't not track down into the recipe? Another problem is version sprawl. So we have a lot of images right out, and which version of that image is correct? Which one should I use? There is a third problem, which is the workflow. And do we have established a process on how can we build or rebuild an image? So we have a workflow to doing that. If we hire someone new, would that be able to learn how to build or rebuild an image on their own? And finally, the nightmare, the auditing one. So are we using an image that is vulnerable to a particular kind of security vulnerability? How can we tell? Because on an ACM study in 2017, they discovered that official and community image that you can find on the hub of container images have more than 180 vulnerabilities, because those images are not being updated for hundreds of days. And moreover, vulnerabilities propagate from parent images to child images. So if I know that you're thinking, I'm not using the hub, the public hub for containers. And another study of this year showed that there are at least 30 vulnerabilities on public container images. And focusing on the last problem, on the audit problem, there is a true story right here. So that's security nightmare. So let's imagine that you're a system administrator, you are using, you have deployed a Java application using Tomcat, and you have containerized that application using Tomcat. And it's Friday night, you are very happy because you're leaving for the weekend, and your CTO comes in and asks you, is our application vulnerable to this particular CVE, common vulnerability and exposure? And what is the process here to check if you're vulnerable? So what do you have to do? You basically have to check every image that you're running and check the version of Tomcat and check the bulletin for that particular kind of version of Tomcat, if that image is vulnerable or not. And that has to be repeated manually for all the images, right? And that takes a lot of time. And your Friday night is even ruined. So your whole weekend is wasted because you have to manually do that for all the images. So how long does it take you to check your compliance status? The whole weekend, a whole month? It depends on the kind of images that you're running and how can you manage them. So at SUSE, we have developed SUSE Manager, which is infrastructure management solution. So it's a complete lifecycle management solution for your servers, but also for your virtual images and containers. But not only it can build the images and rebuild the images, but also among all the other features that check compliance for those images as well. Let's now focus on image building of SUSE Manager. Just a quick round of hands. Who is already familiar with SUSE Manager? Please raise your hands. Okay, really good. Okay. So I have a good graph here that shows how we can build SUSE Manager, but I have something even better. So I have a live demo of it. And very quickly, we have SUSE Manager at the center of this graph because it fetches the code repository where we have the input files, the recipe to create the containers and the virtual images. That can also use a package hub or container hub as an input part. And finally, you have your application packaged as a container or virtual image, and also can be interfaced as well with Open Build Service from SUSE. Let's do a quick hands-on, right? So let's jump on a real live SUSE Manager solution. So right now I have a complete SUSE Manager running on my machine, and I also have one managed minion by Salt registered to that SUSE Manager. So I have actually two machines running here, okay? And this machine is running /12sp3, it's my minion, and I baptized to be a container build host and an OS image build host. What does it mean? So it means that I configured with SUSE Manager that machine to act like a build host. So SUSE Manager, as soon as I'm going to show you what is the option to baptize a machine to be a build host. So I check the properties of this machine, and as you can see here, we have two options, and I check both of them. And what does that mean? As soon as I check those two options to be a build host, SUSE Manager fetches the proper containers and OS image modules and installs them on that machine and configures that machine to act as a build host by simply pressing the checkbox there. Okay? So I already did that for television purposes, of course. And the next action would be, I want to create an image right now. So I want this to be my worker. Okay? I need to do something. So I already provisioned the machine. I already configured that to act as a build host. The software is installed, so I have the container engine running there, and I also have the OS image running there. What do we mean with OS image? OS image means virtual images that can be PXE booted via Salt boot, or maybe Kiwi images, or other kinds of virtual images. So a lot of range of images that we can build with SUSE Manager. So for containers, we are using Docker. For OS images, we are using Kiwi. Kiwi is an utility tool that we developed at SUSE, and it's used for building that particular kind of virtual images starting from a configuration file. And we are going to illustrate a little bit of Kiwi in this session in a few minutes. So I wanted to build an image right now, okay? So there are some things that need to do before creating the image. So I already have my worker. I have already baptized that minion as a build host. I now have to create a profile. I already created some profiles here. So like I said, there is a container type of image and there is an OS image type of image. You can see here that the enabling technology for the building type of containers are Docker files. And as I said, for the OS images, those are Kiwi images file. So it's a profile. It's basically, let's edit one of those. A profile in SUSE Manager for building an OS image or a container image, it's simply as a label to identify this particular kind of profile. The image type, like I said, Docker or Kiwi. The output, where should I put the image that I'm building? So for Docker containers images, we are using a container registry, and we are gonna see what the OS corresponding part is all about. And also we have to specify a Dockerfile URL. So in that particular case, it's the input file, so the recipe. Where is the recipe on how can I create the image using this profile? Let's have a look at that, but I'm sure that you're already familiar with Dockerfile, so I'll be more than happy to show you. Oh, okay, there's a question.
Questions?
Yes, sure.
Oh, I can ask?
Sir?
Yeah, so I was curious, for that, does it automatically take care of tagging, and if so, how does it manage that?
You mean image tagging?
Yeah, so I take a Docker file, I dump it in here, I give it a target URL.
Mm-hmm.
When it pushes to the registry, how does it tag?
Yes, we are going to show you, we're going to show how the image tagging works as soon as we are ready to build the image. So that would be the final part. So right now, I will be getting back to your question as soon as we are ready for building. So the Docker file means where is the input recipe to build the image. And let's have a look at that. So this is the Docker file that I'm using. It's a standard Docker file. We are starting from OpenSUSE. Let me increase the font, obviously. Okay. And the interesting part is this one. So we are adding packages to this container, and we are configuring Apache to serve a specific kind of directory using the index file that we are going to supply into the container. And then we are starting Apache in the foreground. Okay, so it's really simple. The add packages is just a bash script to code zipper and install the Apache package and what's needed to install Apache. Okay, very simple. And now I'm ready to build the image. So getting back to your question, I created the profile. Oh, one last thing I forgot. So there was the output. Let's recap. There was the output, so image store, the input, the recipe on how to create the file, and the activation key. What is the activation key? The activation key is a way to specify software channels that can be used when building the image. What does it mean? That it means that you can specify with a granularity of channels the repos that your image is going to use to fetch the packages to install in that container. So you have the granularity to control which packages ends up in your containers, because you gain all this channel management for SUSE Manager as well. So you can promote packages into a channel based on your particular policy. Yes, question?
Now does it look an activation key? Can you have an example here?
Yes, sure. I have an activation key that we can use. For example, this one. This one is a clone that I prepared for /12sp3 only pool channel. So there are no updates here. And I will be showing you why I chose only pool. So in that case, particular case, I have pool and manager tools. Okay, so in that particular case, I took the pool, I cloned, I added some patches there, but not all of them, because I wanted to be careful for my production, and I don't want to use all of the patches that come from updates. I want to use the base pool, and I manually promoted some of the patches from pool to that part, that my clone that I want to use. I'm sorry.
The name is confusing, activation key.
Yeah.
And where does default then is defined? It's in
Sure.
SUSE Manager?
Yes, it's in SUSE Manager. So I call that default because, yeah, it's the standard name for my activation key, but it's also can be anything like that. So in my activation key, the name is changeable. And the description here, you can see here that I assigned the base channel and the child channels that we've seen before. Okay, so my policy for that kind of channel is I want to use pool and I want to manually promote the patches into that channel. And that can be customizable as well as you want. And yeah, it's a very granular way to specify which packages ends up in your image.
That is awesome. If you update the channel, is there a convention to, I guess, link the tagging with when it was actually built?
You mean like when I rebuild the image?
Yeah, let's say I promote a new patch, right?
Mm-hmm.
How do I tell if the image was built before or after that was promoted in? I love that this has that granularity, but yeah, I was just curious about that.
Yeah, I don't think there is a possibility to do that. But definitely a good idea, so I'll take note after the meeting. Okay.
Yeah, okay.
Okay, so has that answered your question?
Perfectly.
Okay.
It's actually, the activation case is already, it's an existing concept of SUSE Manager.
Yeah, that's right. That works for servers as well. So you can reuse your kind of policy for images as well. So we were at the profiles here, and we were discussing about the activation key. So for this particular case, I'm not using an activation key. That is optional for Docker, but mandatory for Kiwi images. For OS images, that is mandatory. So this activation key is optional for containers, but it's up to whoever is going to build the container. Finally, we can build a container. And how are we going to do that? There is a simple page where you can select the profile that we have written before in the last part, and there is a version tag. So to answer your question, we have the tagging here that you can input there. So by default, it's latest, obviously for Docker, but you can change it whenever you're building the image.
Can you comment it on the list, or is it just that tag?
It's an input field, so there are no, you mean like a combo box or something?
Well, typically when you build an image, you have two tags. You have like latest and then the date or something like that. So it just does latest?
Yeah, you can also change that. I mean, you can type something like that. Right now I'm using latest, and I also have to select one build host. And right now, this list is selected by the build host that we have baptized before. So only the baptized build host, the workers, are going to show up here. And then I can specify when my image is going to build. So for image purposes, I already built my image for Docker, and I already built that. And you can see here that my container was actually built. Now, let's take one step back. I spoke about OS images, and how are OS images different from containers images? So, sure.
Is that input field, is that available through SpaceMD as well?
For SpaceMD?
Yeah.
Yes.
Awesome.
Okay, for OS images, the profile, it's pretty much the same like we have seen for containers. The only difference here is that we are using Kiwi, and we have a configuration file as well as a different OS image store. So an OS image store is where the final image will be published. So for OS images, we have a directory running on the SUSE Manager side, listing all the possible images that we have built. And the configuration file is a standard Kiwi configuration file. The activation key is the same as before, so we have a selection, a granular selection of channels. Now, let's have a look at how the image store, the final image store can look. So it's just a simple Apache listing page. In that case, I already have an install ISO created some days ago, and you basically want to download that image from the SUSE Manager server, and we are going to show that later, and use that particular image into your kind of virtualization platform. Let's also have a look at how the configuration for Kiwi is done. So this file is a configuration file for Kiwi. And where is the interesting part? So it's really a simple file, very short, I would say, and it's very, I would say, self-explaining, I guess. The interesting part is here. You specify which packages are part of your virtual image. So you specify the packages that you want to be there in your image, and then you're all set, because that's the most longest part of the file, and then it's done. So that is my recipe to create my virtual image using Kiwi. We have extensive documentation publicly available for Kiwi, but I would say that this is the most interesting part for a user of building an image. Okay, I created my own kind of images, one for OS images and one for container, right? What happens if I get a CVE audit like in the initial nightmare that I told you about? We have a solution for that as well, because that is something that a lot of people like. So CVE audit, what does it mean? It means that I created two images, one for container and one for OS image. And I'm sure that both of them have the curl package in it. And now I want to be sure that I'm not vulnerable to curl vulnerabilities. So the CTO comes in and says, oh, I've been to this page and I know that we're using curl in our containers and OS images. Are we vulnerable to, I don't know, this one? And it's the same story as before. It's Friday night and you want to leave and you want to enjoy your weekend, and you don't want to manually log into every container image and check for the version of curl. And here we are lucky because we have the two versions that are vulnerable, starting from 736 to 763. So it would be like checking every image and say and see if curl is under that two versions and say, okay, I'm done. But it depends on how many containers you're using, right? And that is the CVE bulletin for that particular kind of vulnerability. What I'm going to do is to copy-paste this particular number that identifies the CVE and have SUSE Manager do the magic. As you can see, I pasted here the CVE number that I took from the web page, and then I do an auditing of the images. And I have two containers that are not affected by this problem, because curl was already updated when fetching and building the image. But I have one OS image that has curl, but we use the pool image and not the updates, but the patch is only in updates. That is why SUSE Manager knows that I'm using a vulnerable version of curl, but I'm not allowed to patch that particular kind of image using my software channel, because my software channel does not contain that particular patch that fixes my problem. But SUSE Manager knows that the patch is available in another channel. So you have to manually, and SUSE Manager suggests you to do that, you have to manually clone the patch from the channel that it's highlighted here from update to my own kind of channel, the pool one. And that was the reason that I used pool instead of not using pool and updates, for showing that SUSE Manager has this ability to show you that the patch is available, but you have to do an action.
So what is it looking at here, the RPM data, or is it actually auditing the image actively? Like
That's right. Okay. Yes. Whenever we are building the image, we are doing an inspection of the packages that we have inside the image. And we are saving that information into our database. Okay? And we have that information as well here. I'm going to show you that. And for OS image, we have the details, and we have all the packages that are inside that image. So I wanted to see if curl, the version of curl, it's 7.37, right? And that was actually in the version that were vulnerable. So SUSE Manager was right? But not only you can audit the image, you can actually trigger a rebuild using the software channel that you have just modified by following SUSE Manager suggestions. Everything clear so far?
Here
Weston.
you're auditing the image in the registry, not the actual container running in either on CAS or on the Docker.
We are auditing the images that we have built and pushed into the container, into the registry, sorry.
So is there an option, as opposed to the CD audit mechanism, which ties into SUSE Manager database, is there an alternative mechanism to do an active scan?
You mean like, what do you mean with active scan?
Like where you actually try to either exploit a container or you try to run code directly against the container. So instead of going to SUSE Manager's database, because I'm thinking about like third-party images that maybe don't tie into that specific mechanism.
Okay, so you mean like running a command into the container or running an exploit into the container?
Right. For instance, let's say I have a repo that's not managed actively by SUSE Manager. Let's say I have an Ubuntu image or something like that. Is there a way to basically audit that image? Or
Currently not, because we manage software channels and we know the...
so it's not by software channel.
Yeah, but we can actually run commands into the container as well. So right now I'm running the registry on the minion, and I'm running Apache container on the minion as well. And I'm doing that using Salt. Okay, so we basically have a way to run commands on the container using SUSE Manager and Salt, but not targeting exploit as well. But if one gets the correct information on how to run an exploit and write a Salt files for that, you can do that.
No, this is perfect because it's faster, but it also, again, that's the only use case that I can think of that would be problematic. So.
Okay.
There was a question maybe?
I was going to comment that please be aware this is updated nightly. So if you want its current state, you need to, it's noted in the box below.
Yes, that's right. So we do the CVE audit population every night. So there is a task that does the scanning of the packages and matches for the CVE auditing every night. So that information has already been done, obviously for television purposes, but as soon as you build the image, you can also manually trick that job that does the manual CVE scanning for every image. But that has been running nightly every day for scheduling.
Just if you register or build a new one, you need to trigger it.
Okay. Any more question about this particular kind of feature? Okay, I guess not. So let's jump back on the hands-on. Okay, I've shown you everything on this particular matter. I had backup slides, but I had live demo that was better than having slides. So these are the things that are already explained. Let's do some recap here. The configuration file is the input file, and the activation key is the software channel used, and the image store is the output. Where should I put the built images? So container registry on a directory served by HTTPS running on SUSE Manager. Please be aware that SUSE Manager does not do the dirty work. I mean, SUSE Manager does not build the image. It just fetches the images from the worker and copy on the SUSE Manager side. So the dirty work is done by the minion and not by SUSE Manager. SUSE Manager only serves the image there. So as long as the minion has completed building the image, it says, okay, let me fetch that from the minion and I'm going to serve it, not you. Okay? That was the configuration file. Kiwi. So I had some question about Kiwi. And Kiwi is an utility, like I said, to build system appliances and can create an image file from configuration file like we've seen, configuration.xml that I've shown you, the configuration with the packages listed at the end. And there are a plethora of formats for outputting an image. Right now, we have built an image using QEMU. And yeah, I wanted to show you the final output. So here, I created an image using SUSE Manager, and that has been published into the OS Image virtual image store for OS images. And I proceeded in downloading that already from the SUSE Manager server, and I want to run it on my machine. So let's see what happens as soon as I fetch the ISO and use libvirt to run it. So here I'm configuring a virtual image running that ISO that I downloaded from SUSE Manager. And what happens? Wow. So you can see that. Let me enlarge the screen. Wow. Nothing has changed. But anyway, I hope you can read that we have built an image that is currently running on libvirt. So it's actually a virtual image. That's what we call an OS image. And it's actually working on my libvirt setup. Okay? So let me also do the test for the container image that we have run. Okay. So here, I'm running the final container that we have built using Docker. You remember that we were adding Apache and running an index file. So I'm running that containers into the minion part, fetching the image from the registry and running the image on the minion. And you can see here that Apache is responding on that particular minion. So for all of those who want to be sure about that, let's see. Here I'm on the minion, and you can see here that I started the Apache container built using SUSE Manager on the port 80. So it's actually serving the web page using Apache running from a container. Okay? So that was the final output of my image building. Yeah, and we already talked about the Kiwi configuration file. And that is the selection of software channels that we used when building the images to answer the question that we had. And finally, the security audit. So yeah, like I said, the packages are listed here and you can see them. And we are using that for CVE, security checks, and also for OpenSCAP. The recaps. So finally, the evolution of CADL. We discussed about the 4 notable problems of CADL and PET, and how do we solve every problem with SUSE Manager. So configuration drift. The instruction to recreate or create the image are versioned in a Git repo. You have seen that I'm using a GitHub repository that is public and it's already linked in SUSE Manager. And every change committed to the recipe is used by SUSE Manager to build the image. So every different configuration that you are doing to your configuration file, to your input file, is versioned, and SUSE Manager takes exactly the branch that you specify and takes the tip of that branch to build the image. Version sprawl. Which is the correct version of the image that we want to use? So we solve this problem by using the because we manage the entire life cycle of the built images, we can actually be sure that SUSE Manager is handling the correct version. So we can be sure that SUSE Manager is managing correctly the whole life cycle of the container and OS images, and can actually trigger a rebuild whenever it's requested, and also can do CVE and security audits and compliance check on those images. The workflow, like I said, if we have a new hire, is there a defined workflow that he can learn and jump as soon as possible on how to build images? Yes, for SUSE Manager we have defined a workflow. We define a store, so where the output goes. We define a workflow to build a profile, to create a profile and build the image using that profile that we specified. And creating a new image or a new container, it's as simply as we did during the live demo, pressing some buttons and filling up the input fields and pressing a button to start the build. Auditing, yeah, the security nightmare. So we have seen in the example that we were asking if curl was vulnerable in our images, and we saved the weekend for the poor system administrator because we were actually being able to answer the question if we were using curl and rebuild the image in a matter of minutes, I would say. So we have that covered. Use cases for this particular image building feature. One notable use case is SUSE Manager for Retail. We are actually using image building for SUSE Manager for Retail, and that means that SUSE Manager for Retail is building images for point of sales devices using image building. And basically they build the image using SUSE Manager, and then they do PXE booting via Salt Boot to deploy the final image into the POS, yeah, the point of sale structure there. Another use case that I thought this morning and I was asked about is using SUSE Manager to manage hybrid cloud and hybrid deployment. So basically you have SUSE Manager running locally, and your registry on your image store can run on the cloud. So you basically build the image locally and you push the final image to the cloud because you want to use the cloud images that you have manually built with SUSE Manager on the cloud. And your imagination is the limit, I would say. So sky is the limit for this particular feature. We have other use cases that we can think about, and that leads to the final Q&A session that we want to achieve. So I want to have some questions from you. We already have some interesting questions from you, but there are some notable use cases that we can think about, and maybe we can do that right now. So what do you think? Sure, yes. So the final question would be, we have illustrated some use cases for this particular feature of image building. But we want also to know, what do you think about this feature? And if you can imagine if this particular feature could be used in a different approach. So we are actually using for SUSE Manager for Retail, but also for managing hybrid clouds or multi-clouds. That could be useful as well. What do you think? Do you have other questions? So that's your turn to ask me some questions or start a discussion about this feature. So we have one.
When you talk multiple clouds and then a general cost case on transporting things back and forth to the cloud is mainly the problem. So if you have a central repository where you have your images, and when you deploy you have to transport it across will cost a lot of money and traffic costs. Is this supported with the proxy infrastructure?
You mean using SUSE Manager for proxy to proxy the transferring to the image to the cloud?
So that you only do it once, yes?
We can think about this. So the short answer is it's not supported at the time, but we can optimize that maybe in a future development. So I'm also taking note of this.
If you're full public cloud, SUSE Manager could be running in the public cloud and then...
That's another option, yes. So if you're running SUSE Manager on the cloud and in a bring your own license fashion, you have SUSE Manager running on the cloud and you can publish the image directly on the cloud.
That was also what I would do, but if you have multiple clients in mind and you
Yeah.
want to centralize things.
That is why I was imagining like building the image locally and then publish the image on the cloud. But as you said, you have, if you're using multi-cloud, then you have to publish the image on every cloud, right? And maybe with proxy, and I cannot say it for sure, but we can do some optimization for the proxy and say to optimize it to deliver the image only once. So I would take note about this idea. Thank you.
Yeah.
Sure.
So whenever you change the Docker file or the configuration for the US image, is it possible to trigger the build automatically using APIs?
Yes, using API, yes. Not automatically using the UI. But using the API, yes, that would be possible.
Are secure Docker registries supported?
Secure Docker registry, you mean HTTPS Docker registry?
Right.
With like username and password login.
Sure. Yes, yes.
Okay, and then the second question was, are any OCI builds like in your pipeline for features, or is it mainly Docker file? That's it.
It's mainly Dockerfile for the moment, but we are actually looking into alternatives for that. Sure.
I was actually thinking in the same direction because Cloud Foundry uses Dockers, but also the, can't remember the name now. Anyway, the other sorts. And are there any plans for supporting that as well, in both types?
Yeah, there are no official plans at the moment, but we are actually looking into offering alternatives to the container engine.
Okay, and what about the build tools or build packs? Any versioning? Because so one of the problems is that you get fetched here all from the internet. So basically the same problem that SUSE Manager solves on a package level, it would also benefit if you could do that on build packs from in Cloud Foundry or something like that.
Yeah, there is no support at the moment for that, and we definitely have to look into that for build packs as well.
Our
Sure.
product already. I think we actually the stem sell straight for OpenSUSE.
Okay, yeah.
So and then you can create build packs on top of that, and then
So you can stage it.
so TAP will do that. Yeah, your droplets. Yeah, those get generated by Cloud Foundry directly. Though.
Okay.
So.
Question? Yes.
You missed a huge one, disaster recovery.
Mm-hmm.
The traditional approach is you back up every server like it's a snowflake.
That's right.
And you spend multiple, lots of network bandwidth to copy it somewhere else, okay? You now stand the thing on top of its head. The only thing you really need to back up is your recipe, as you called it.
Yeah, definitely. So if you have a snowflake, like a pet, whenever it gets sick, you cannot replace it easily. Even if you had disaster recovery and you spend a lot of money on it. So you have both a lot of things for your pet, but suddenly when it gets sick, you're sad. And even if you have bought a lot of things for it, they will not help you a lot because you're missing your pet, right? So yeah, if you treat your server like cattle, then you don't need a disaster recovery as well. You just have a central point where you save your complete infrastructure as a code in a especially in a Git repo or in a version way of saving that.
All right, so let's take the next step. my SUSE Manager right now is in one data center. That data center gets hit by a comet.
Mm-hmm.
So how do I clone my SUSE Manager so that it's backed up? So the SUSE Manager is not a snowflake.
Yeah, we have HA for that. We are looking into HA for SUSE Manager.
Okay.
It also has a Postgres database you can back up remotely, and I think that's actually best practice for deploying it.
Yeah.
That's my answer.
Further, there's also a system profile that SUSE has written called machinery that you can take basically an arbitrary operating system, and it'll look at your RPMs and profile them, and then any untracked configuration changes you've made as well. And so you can like back up the system description, and then you can build that into an image in Kiwi.
Yeah, but SUSE Manager should be able to manage itself in some sense, you know. So
Yeah, we have best practice on how to back up properly SUSE Manager as well. But we're also looking into HA for that.
I got one. Recently you pushed, or SUSE pushed, Ubuntu support.
Mm-hmm.
Is that possible to build Ubuntu images now, or is it?
You mean using Ubuntu minions or using Ubuntu images? Because it's different. I mean,
I would have definitely just containers, also images.
yeah, it's possible to use Docker files to build Ubuntu images, or OS images file to build Ubuntu virtual images as well. So if you have a minion running Ubuntu, you cannot build images on that yet. But if you're using a recipe like recalled configuration files targeting Ubuntu, you can do that.
So Kiwi already has the ability to build other OS images, and that's the tooling SUSE Manager is using on the
Yes.
host.
Yeah, but I was more into
Containers.
containers.
Mhm.
Yeah.
But yes.
So in that case, we used OpenSUSE, but nothing stops you from using Ubuntu. But please be aware that if you're using Ubuntu, you do not have the CVE audit and the other features. That's a hard question. Any other questions?
You just change your from line to like from Ubuntu latest, or
Right, you change your from to Ubuntu.
you do need an active scanner. So you tie that into like Jenkins or something, so it does an active scan of your image or your Docker component like after it's built. That's what I was kind of asking about. That saves you some steps now.
Okay. If there are no other questions, I would say thank you. And one last question from me is that if you like this session, please rate it. There is the number of the section there. And otherwise, thank you very much for attending. And I hope you enjoy the other remaining session of this SUSECON. Thank you.